Yeah, you may not know it, but Al Gore was in town last week, and your very own Jim here had dinner with Al Gore secretly. And the waiter come up to them before the dinner while he's getting this set up. I'll tell you this story if you don't let anybody else know. The waiter came up and they said, "I'm sorry, men, but we've only got 2 entrees tonight, filet and lobster tail." And they said, "Okay, so that's good." And they said, "Mr. Rocky, what would you like?" And he says, "I'll take filet." And the waiter says, "And the vegetable?" And he says, "Oh, he'll have filet too." You ready?
Yeah.
All right. So before we get started, I got to recognize my primary editor, Gordon Tom, over here, with his. That's not his daughter. That's actually his wife that's with him. Without Gordon, this book, it would have been a book, but it wouldn't be nearly as readable. I would send chapters to Gordon, and he'd do his wordsmithing on them and polish it up a little bit. But thank you so much, Gordon. Great job. Yeah, so I didn't start out to write a book at all. I started out, I knew that there were some things about the climate change debate that as a geologist, I knew were not true. And I suspected several other things, many other things within the debate were not true as well. So I started out to seek the truth, because I heard some things from the skeptical side that I knew were wrong as well. So I went back, looked at the base data, the data you're going to look here, the charts. A lot of these are from NASA, NOAA, the UN. It's all base data. I've got 14 pages of references in the back of the book. You don't believe anything in there, you go look it up in the references. You can Google it, find it yourself. But everything is clearly sourced and referenced with base data. So let's get started, Jim. So I'm a geologist, and one of the things that's sorely lacking in the climate change debate is the geologic long-term perspective that we will look at here. Too much of the argument that we hear from the Intergovernment Panel on Climate Change, IPCC, is based on very limited time frame, whereas I went back and you place that, if you only look at the last storm, the last year, the last several years, decades, hundreds, even thousands of years, without placing what we're seeing today in a longer-term perspective, you really get a skewed perspective. And that's one of the things I want you to look at as we go through tonight, how by looking at a small-term data, it gives you one opinion on what might be going on, but yet you look at the bigger, longer-term data, you get a completely different aspect. And so these are the inconvenient truths that we'll be putting into the long-term geologic process. And as a geologist, one of the primary factors, the first thing you learn as a geologist in school is the present is the key to the past. In other words, the same processes we see in process today, we're driving those depositional forces in the past. So if we want to learn about, we'll go to look at deltas that are like that. And the same process were taking place in the past. We turn that around, I think, for climate change, and now we look at the past is the key to the future. We can look in the past and see when CO2 levels were at 4, 10, 15 times as high as they were today. What happened to the Earth's processes? So let's get going. So there's really no disagreement. This is the big key. We know that CO2 has been increasing very slowly at the beginning of the Industrial Revolution. We'll take a look at that in more detail. It really started speeding up around after World War II. Nearly all of those CO2 that we've seen that's added is man-made. That's there's a lot of lines of evidence to point to that, and I don't argue with that. Additionally, temperature has risen about 1.5 degrees Fahrenheit since about 1850. So those three things, you heard about a 97% consensus. There's probably a 97% consensus on those three things. There's serious disagreement, and this is where skeptics of catastrophic man-made warming differ from what I'll call the climate alarmist segment. And that is, the climate alarmists will say that the temperature increases we've seen are primarily driven by the man-made increases in CO2, and that those temperature increases will lead necessarily to catastrophic climate events. Drought, forest fires, heat waves, climate-related deaths. where skeptics like myself will admit. We hear a lot of the science denier. I'm not a science denier at all. I admit that CO2 is increasing, and that increase in CO2 necessarily has to add a little bit to the temperature increase. It's a greenhouse gas. But I believe that amount of increase in temperature is tiny and overwhelmed by the natural forces that have been driving the temperature for hundreds of millions of years. Those same forces that have been driving temperature for the last 650 million years didn't cease to function at the turn of the 20th century. And that's what we're being asked to believe. Good. The first inconvenient fact in the book, and no, I'm not going to go through all 60 inconvenient facts, but the first inconvenient fact, if you Google greenhouse gases, you'll come up with a chart, something like you see on the left. If you go to the National Geographic site, you'll see a chart that's something like you see on the left, where they mention that carbon dioxide is the primary greenhouse gas. What they fail to mention is what the true primary greenhouse gas is: water vapor, and it's as high as 90%. It can range anywhere from I've seen 70% to 95%, depending on, where what the water vapor content is. But the chart on the left is the true greenhouse gas percentage and what's driving that. So that's the first inconvenient fact. This is rarely mentioned. They don't necessarily hide it, but they don't talk about it. Because if you focus on the chart on the left, it's easier to drive that climate alarm that's necessary to impose the economically destructive taxes and regulations that they want to enforce. Good. The other inconvenient fact here is that as CO2 is added to the atmosphere, each additional molecule of CO2 will have less of a greenhouse warming effect. Kind of an example would be if you put a coat of paint on your front window. That first coat of paint would block out a lot of the light. The next coat of paint you put on your window will block a little bit more light, but not nearly as much as that first coat of paint. And every subsequent coat of paint blocks out a little bit more, but declining as you go through. And it's somewhat similar with CO2 as we're adding CO2 to the atmosphere. And this is the reason with increasing CO2, there's less warming effect for each molecule. That's the reason we didn't have runaway global temperature increases when we had CO2 at 6,000 and 8,000 parts per million, or 20 times, 15, 20 times what they are today. Good. We first started taking CO2 measurements directly at Mauna Loa Observatory back in 1958. We've seen about, I'm going to have two numbers I want you to remember. One is 400 parts per million. We're at 406 right now. That's an increase. Before the Industrial Revolution started, we were at about 280 parts per million. So we've increased about 120 parts per million, about 40% since beginning of the Industrial Revolution. Good. And again, this CO2 increase that we've seen is from man-made causes, mostly fossil fuel burning. I'm not disputing that at all. Coal, oil, natural gas. Interesting, cement manufacture also contributes some. Good. This is CO2 emissions, man-made CO2 emissions, dating back to the mid-1700s. And you can see that there were very, very minimal man-made CO2 emissions until around the mid-1800s. We started getting a little bit of a ramp up. But really the big peak and increase in CO2 really started after World War II in the mid-40s. And that's important to remember as we go through this, that 20th century saw an impact, but really it's been since the mid-40s that we've seen an increase. Good. And we're going to see that same chart superimposed on other charts as we go through. We're going to compare a lot of things to that CO2. We'll take a look here. This is 400,000 years of CO2 data. This is from Antarctic ice cores. Don't ask me about the detail. I don't want to go into the detail of how they do it, but it's complicated. But both sides agree that it's accurate. You can see we're up here at the last. Those are 4 interglacial periods. During the ice ages, CO2 levels fall precipitously. And you see at the bottom right, I've got a little red arrow. I have 182 million parts per million of CO2. I say it's dangerous. We'll take a look at that in a minute. But you do see that the 400 that we're at right now is about 120 parts per million higher than the other interglacial cycles we had. And then if you look at just this, that goes, wow, that's quite a bit. But let's take a look at this in the long-term perspective. We're looking at 600 million years of CO2 data. The blue line at the bottom is where we are today. Nearly all of Earth's history had significantly higher CO2 levels than we have today. In fact, we're in the Quaternary period now. The average CO2 prior to the period we're in right now was 2,600 parts per million. That's 6.5 times our current levels. Looking at the long, let's go look at the next one. That's 6.5 times where we are today. Looking at the long-term perspective, we're actually in CO2 impoverishment. Everything you've probably heard, anybody in this room probably thinks, everything you've heard carbon dioxide levels are dangerously high levels, right? They're not. We're CO2 impoverished. And that's a bad thing. This is probably the scariest chart in the book. This 140 million years of CO2 data. And I call it it's a dangerous chart. The red line at the bottom is 150 parts per million. That's the minimum threshold at which plant life can survive. Now you look at that back 140 million years ago, we were at 4,000 parts per million. What are we at today? 400. Very good, you're paying attention. So we're 400 today. There's almost a direct line heading from 4,000 directly to that red line where plant life can't exist. That's a climate apocalypse. We're at too low levels of CO2, not too high. Good. This is the main temperature chart that's used by Michael Mann. Thank you. Michael Mann and the IPCC and a lot of the climate alarmists look at this chart. And I've superimposed CO2 emissions on this. I want you to look at this, and if you look at that, you could probably make a reasonable argument that there's some linkage between carbon dioxide increase and temperature, am I right? Just looking at that. Let's now take a look at the Central England temperature record. Well, okay, before we go to there, we mentioned that CO2 started increasing in the mid-40s after World War I. This is the same temperature record, looking at that period. The blue are areas that either temperature was declining or was stable, not increasing. 70% of the time since 1945, temperatures were either declining or stable. Obviously, something else is driving temperatures other than just CO2 alone. Good. All right, we just looked at this graph. I said this is the one that's used to document a lot of the climate alarmist arguments and the relationship between CO2 and temperature. Let's take a look at a longer term perspective. This is the Central England record. It goes back to the year 1659. All right, the red data is temperature. The blue data is CO2 emissions. Looking at this, we see that the temperature warming trend that we're in right now actually started in the year 1695. It started over 300 years ago, the year 1695. The next 40 years, from 1695 on, it had by far the greatest warming increase that's been seen since that time. In fact, it's 4.5 times what we saw in the 20th century, in the 40 years from 1695 on. So I take a look, we really look at the same data, but in a longer term context. Do you see a correlation between CO2 and temperature? No, I don't either. What we see was temperature actually increased twice as much in the period from 1695 to 1850 as what temperature has increased from 1850 to now. And that, prior to 1850, that was almost entirely, or probably entirely, naturally driven. We could not have been adding temperature increases due to CO2 at those low levels. So we didn't have, looking at that chart, those same forces that were driving temperatures higher, again, did not stop at the beginning of the 20th century. And that's what we're being asked to believe. We're saying, oh, well, we had natural forces driving twice as much temperature increase, but those natural forces ceased to exist, ceased to function at the beginning of the Industrial Revolution. Temperature, glacial shortening and sea level rise go hand in hand with temperature rise. This is a look at glacial shortening. There were, I believe there were 69 glaciers around the world that were used to create this chart. And what you'll see here is that glacial shortening began about the year 1800, and by early 1820 or so, the glaciers were in full retreat. And that retreat of the glaciers continues today at about the same rate. Now you say that, Greg, that we started warming in the year 1695, right? Well, why did it wait until 1800 until they started retreating? And that's because it had to warm up enough. We were mired in the severe cold of the Little Ice Age. It had to warm up enough that summer ice loss had to exceed winter ice accumulation. And it was at that point, when it finally got warm enough, that the glaciers started retreating. So that's and then we'll take a look at, again, this is sea level rise. You can see, again, sea level rise goes hand in hand with warming and also with glacial retreat. As glaciers retreat, that feeds that water that's melting, goes directly into the oceans and raises sea level. One thing you may not know is that we could melt the entire polar ice cap, northern polar ice cap, and it wouldn't affect sea level 1 millimeter. And the reason for that, and the same goes for the Antarctic ice shelves, the ones that are floating. Any ice that's floating on water, like the northern polar ice cap, the Antarctic ice shelves, not Antarctic itself, the ice shelves, if you melt that, the water that's displaced as it's melted equals the water. You can do that experiment yourself at home, put some ice in a glass. I've got a picture of that in the book. But you can put ice in a glass, go ahead, put it in the microwave, melt it, and you'll see that the water level stays the same. And it's the same principle here. Good. This is one of the key charts in the book. This is 10,000 years of temperature data from Greenland Ice Core project. And you can see that the warming trend that we're in right now, which is marked number 10 here, again, this is Greenland ice cores that are taken. This dates back to the beginning of this interglacial warming period or the end of the last ice age. And you can see that there were 9 significant warming periods prior to the one we're in right now. Each one of them had higher temperatures than what we are right now. And in the book you'll see, I don't have it here, but 5 of the 9 all had higher rates of temperature increase than what ours is right now. Dr. Michael Mann would tell you that where we are today is unusual and unprecedented. And I think by looking at this chart and some other work we'll do, we'll see that Dr. Mann is incorrect. It's not unusual, it's not unprecedented, it's in fact quite usual and predictable that we are in a warming trend. And what we'll see here too is that warming is really good. Let's go. One of my favorite parts of the book was the relationship between civilization and culture and temperature. And especially over the last 3,000, 4,000 years, there's been just a direct correlation between the rise of civilizations, the great empires, and warming trends. In each of the warming trends, the human condition prospered. People were able to feed their populations. And in between each warming period, it got cold, and really bad things happen when it gets cold. Mass depopulation, starvation, disease, you're unable to feed the population. For example, the Minoan warming period, that was the rise of the first of the Mediterranean, the Mycenaean culture around the Mediterranean, the rise of Akhenaten, the first great Egyptian empires. And then we see as we got what's called, after that we got into what was called the Greek Dark Ages or the Vandal Minimum. Man, things went bad. Civilizations collapsed, people died, mass depopulations. And we see that repeated time and again. For example, in the Minoan warm period, they were raising a grain that's called millet. I don't know if you know what millet is. They were raising millet in Scandinavia. The only place it's raised today is in subtropical and tropical parts of the world. So we know that it was a lot warmer in the Minoan warm period. The Roman warm period, the time of Christ, again, civilizations grew up. The Romans prospered. The first great civilizations in China, the Han Dynasty, established itself. And then it got bad. We had the Dark Ages when it got cold again. Again, mass depopulations. I'm not going to say that the Roman civilization and the Chinese civilizations collapsed entirely because of the temperature. It'd be unfair to do that, but when it gets cold, you see summers they're very wet, very cold. You can't raise crops, crop failures, mass depopulations. And when that happens, if you're the emperor, it's hard to feed your population. And you're going to have mass discontent, riots, just the seeds of destabilizing the empires that you've built. And then again, in the medieval warm period, I will say that the Roman warm period, there were citrus crops being grown in the north of England near Hadrian's Wall. Okay, so we know historical records tell us a lot of this. Medieval warm period was considerably warmer than that. We know that because we know the Vikings established a colony on Greenland, right? You all know that. Well, did you know that right now there are Vikings still buried deep in permafrost on Greenland? It had to have been a lot warmer than it is today, right, for that to occur. And there's huge number, thousands of historical documented cases of this occurring. So again, comparing today to the old times, the period we're in right now is not as warm as these other three that I'm showing here. And there were even warmer periods before. So after the medieval warming period went into the Little Ice Age, which again was a bad time. You remember the cold that Washington suffered at Valley Forge. The entire cod fishing population of the North Atlantic was destroyed. Iceland lost half its population. Those are bad things. And in each case, we're seeing really bad things occur when it gets cold. Help me out here. I know you're a 912 group. Who wrote the 5,000-year leap? Come on. You know it. Okay, I can't remember his name, but Clausen. There you go. Very good. You get a star. So, Clausen called this period the 5,000-year leap because we had 5,000 years of an advancement of civilization from the 1800s. We were not too dissimilar to how they lived 2,000 years ago, 3,000 years ago. The primary means of transportation was by horse or ox-drawn cart, written communication or oral, and then we've advanced to where we are today. I'm not going to say that it's due to temperature, but it would have been much harder for us to make the advances we've made to civilization today if we were still mired in the temperatures of the Little Ice Age. Because when it's warm, you can grow crops, people can dream, they can create art sculptures, they can do great things. And when it's cold, the people in charge and the families are grubbing for the food for today and tomorrow. Their main focus is on feeding their family, not on sculptures and creation and thinking. Go ahead. This is a little longer term of historical temperature records dating back 60 million years. And you can see right now we're in a long-term ice age right now. We're actually in some of the lowest temperatures that we've seen in we are right now in the 60 million years. Good. Good. Now we'll talk about too, when I was in college in mid-70s, there was a lot of talk. Just remember, in the mid-70s, we were just exiting a 33-year cooling period that started from the mid-40s, ended at about 78. Remember those terrible winters? If you're old enough, if you're my age, you remember how 77, 78, horrible, horrible cold. And then it started warming again. But at that time, the main talk was how there was a lot of talk about us entering the next ice age. Well, we're now 11,000 years into this interglacial period. These interglacial periods last anywhere from 9 to 12. Some have lasted as long as 15,000 years. So the next ice age could be coming. It could happen in the next 100 years. Might happen in the next 2,000 years, but it's going to happen. And when it does, it's going to be bad. This is the extent of the ice age in the last glaciation. Nearly all of Canada and most of the United States will have to be abandoned due to the ice, as will most of Northern Europe. All right? Looking at this, I think an argument can be made that Trump might be building his wall on the wrong border. You know, we're going to have 80 million Canadians coming down with their toques on. You know, so my advice to you is either buy some mittens or maybe better yet, some property in Costa Rica, because when this happens, it's going to be bad. This will be accomplished or accompanied by mass depopulation, hunger, starvation, great turmoil. That's scary. So the first half of the book I dealt with the technical aspects: greenhouse warming, CO2 temperature, just to make sure that everybody got their basics to understand that. In the second half of the book, I dealt with what I call the climate apocalypse events. You know, it's too much rain, it's not enough rain, it's too much snow, not enough snow. You know, there's increasing toenail fungus. There's all, it's crazy the things that are tied to climate change. So the last half of the book, I took some of the big issues of these climate apocalypse events, and I dove into them, and I was actually quite surprised. I was having a conversation with a gentleman here before about forest fires, and I thought forest fires were increasing. I did. And I started getting into the data, and lo and behold, the voluminous data tells me that no, worldwide, forest fires are decreasing. We'll take a look at that in a minute. That's just one example. So I was personally surprised at a lot of these things that I personally thought were increasing, and I thought they were because the media, it's a media-driven hype. You know, if there's a community goes up in flames, we talk about it. But if we go through 15 years and nobody dies with a forest fire, mild weather does not make for good entertainment. So we hear about the bad stuff. Go ahead. A lot of these things that are contrary to what I thought, and I'm sure most of you think, is that the world is drying. It's turning, they call it desertification, that most of the planet's becoming desert-like, and that drying of the earth is leading to increased forest fires, increased drought, increased heat waves, things like that. What we find is just the opposite. Because of rising temperatures and increasing CO2, we're seeing an increased soil moisture content and a significant increase in soil moisture content throughout most of the world. This is from NASA. This is readily available on the NASA website. The green represents areas of the world where vegetation has been increasing for the last 30 years. And the brown, if you can even see it, means areas that have decreasing vegetation. In other words, desertification is taking place. Zhu is the author of this. He stated that upwards of 50% of the earth has seen an increase in vegetation over the last 30 years, and that only 4% of the earth has seen a decrease in vegetation. That runs full in the face of everything we've heard, is not. And the reason for this is, again, soil moisture content. Soil moisture content is driven primarily by two factors. As you increase temperature, and temperature is increasing, the water vapor in the atmosphere can be increased. The atmosphere can hold more water vapor in the atmosphere, which leads to increased precipitation, okay? The second factor is CO2 fertilization. The main factor in vegetation and drying of the soil is that as the plants breathe in and out through the pores on the bottom of the leaves, it's called transpiration, that's the main water loss from the plant, all right? Because of CO2 fertilization effect, the plants don't need to be, what we call it, breathing in and out. The plants don't need to be transpiring as often. That means they're not losing moisture. That means they're not taking it out of the earth. The moisture is staying in the soil instead of being removed. And this is pretty well documented. The ones we've looked at for greening of the earth and increased vegetation all point to those two factors. Something you've never heard, and you're going to go, really? Really, Greg? Is if we look at the Western Sahara, it's called the Sahel. 300,000 square kilometer area of the Western Sahara, the Sahel, is turning into a lush grassland. And the people that are studying this, there's amphibians actually moving into this area. There are people moving back into the Western Sahara where no one has lived for thousands of years. And you can Google, if you don't believe me, Google NASA greening Sahara when you get back home. NASA greening Sahara, easy to find, and you'll see some really interesting articles about that. And the authors of the studies of this attribute it to global warming and the increased precipitation. I had no idea. Has anyone else ever heard of anything like that? I know Gordon had. He helped me. He rewrote that chapter of the book with me. But and this is one of the big. This right here, I think, is the key for why the Earth is prospering because of rising temperatures and increasing CO2. It's due to increased water vapor in the atmosphere and increased amounts of CO2 fertilization. Both of those are really good. Thank you. Go ahead. So again, that's just to give you, I want to talk about that because that gives you the basis of things that are really, it almost sounds counterintuitive that we're going through global warming, but droughts are declining. This is, again, in the book, I reference and source all of this, where this came from. And a lot of this is from NOAA and NASA data, although the papers were written by other research teams using that NOAA and NASA data. So again, we have a long-term drought, 30-year decline in drought. Okay. Interestingly, too, this was a study done of the most severe and intense droughts of the 20th century, and there were 30 of them. Yet only 8 of the 30 occurred since the year 1960. If we were going to see impacts of increasing drought due to rising temperatures and increasing CO2, should we not be seeing some effect of that? And that's the same question I'm going to ask for all of these impacts. When we look at these climate apocalypse events, they're based on climate models that are severely flawed. The climate models the IPCC uses have been proven to be 2.5 times, predict 2.5 times too much warming, and actually in the tropics, 3 times too much warming. So these are climate apocalypse events based on climate models rather than actual data. Go ahead. I talked about forest fires, and it's kind of touchy, especially with the forest fires, the property loss in California. I just looked again to check with the National Interagency Fire System today on their number of fires. We'll look at that next. The number of forest fires in the United States is not increasing. And worldwide, most of the work on forest fires has been done in the Northern Hemisphere, Asia, Europe, North America. The Canadian Fire Service actually stated, they had a lengthy study on forest fires in the Northern Hemisphere, and they stated that every study that they looked at, every empirical study that they reviewed, concluded that either forest fires were not increasing or that they were decreasing. And again, I thought, before I went in and looked at the data, I thought forest fires were increasing. I did. I just made that assumption. Jim? You're right? Yeah. Yeah? So this is a great chart that Craig Gidso and his team down at CO2 Science, they did extensive studies on what increasing CO2 means to the top 45 crops in the world. They provide over 90% of the food production in the world. This chart is in the book. And you can see if we increase CO2 content by 300 parts per million, this is the percent increase that we're going to have on the main food crops in the United States. Is that not a good thing? Isn't that, this bodes well for the human condition. We can feed the hungry in the world due to more CO2. There's a reason that greenhouses pump CO2 into their greenhouses, because CO2 fuels plant growth. I mean, if we look at this, this is very conclusive. Again, this is laboratory studies where they actually measured all this. Good. And again, we look, I want you to think too, this is food production. This comes from the UN Food and Agriculture Organization, directly from their data. And I've charted increased CO2 data and temperature on this. I'm not going to tell you that the increase we've got in the grains, this is grain production in there. I'm not going to tell you that that's due to increasing temperature and CO2. It sure hasn't hurt. It sure hasn't hurt. But yet, if you read most of the information from the alarmist groups, this is the one thing that they rant about, is about famine. It was going to harm the food production in the world. If that was going to occur, shouldn't we see some indication of that by now? Shouldn't we? I would think so. We see no indication. The only indication we see is increasing food production. We can look at that. I looked at a number of parameters. I selected some of the greatest examples. I think this is a great chart. Increasing CO2, increasing temperature, and food production continuing to rise. Again, a lot of this is due to mechanization, fertilization, and other things, but increasing CO2 and rising temperatures. Rising temperatures, too, has the combination of having lengthened growing seasons. That means that when you have a lengthened growing season, killer frosts arrive earlier in the spring and start later in the fall. You can get more plantings. You can grow more food. Okay. Heat waves, again, the soil moisture content from a lot of the work, it indicates that it's the decrease in heat waves is due to that increased soil moisture content, because that tends to alleviate the heat waves. And global warming primarily affects nighttime temperatures rather than daytime temperatures. So that's another alleviation there. But you'll see here that the peak in heat waves occurred in the 1930s, and it's stayed pretty constant. We'll take another look at the next one. This is a chart from John Christie of the percentage of the United States weather stations. There are almost 1,000 of them across the United States where the temperature exceeded or reached 100 degrees. And you can see there's been a strong decline in these severe heat waves since the mid-30s. This is pretty clear. And again, this is from John Christie's testimony before Congress last year. Hurricanes are one of the big, we heard with Hurricane Harvey and the others this year, we saw 3 landfalling major hurricanes that hit the United States. They made a lot of it and tried to connect it with global warming. However, the facts are that we had just gone through 12 years of no major landfalling hurricanes in the United States. That's the longest period of time to not have a major hurricane hit the United States. The previous record was 8 years, and that was back in the late 1800s. So other than that, we had 12 years of no major landfalls, and now we get 3 in 1 year, which is not unusual at all. It's actually low. And of course, they tie it to climate change. But if we look, this is hurricanes, long-term hurricane data is hard to measure, because prior to the satellites, a hurricane could rise up in the North Atlantic and then dissipate. No one would know about it. This is landfalling hurricanes that hit the United States. NOAA estimates that any landfalling hurricane that hits the United States, dating back to 1850, somebody's going to recognize it. So this is pretty good data showing a decrease in hurricanes. Good. Let me just talk about even the IPCC, Intergovernmental Panel on Climate Change, agrees that there's no correlation between hurricanes and global warming. What they've gone to, both the IPCC and some of the alarmist groups now recognize and admit, because they're confronted with the data, that, okay, there's not an increase in number of hurricanes, but they're increasing in intensity, okay? Christopher Landsea at NOAA did a study on this, extensive study. And isn't that a great name for a meteorologist? Christopher Landsea, but almost as good as a geologist named Wrightstone. But there's Christopher Lancey studied this, and he concluded that indeed there was an increase in intensity in hurricanes due to global warming. He concluded that it was 1 to 2% increase in wind speed in a hurricane, in a Category 5 hurricane. Okay, so what was the big Category 5 that hit a couple of years ago? That hit devastated, whatever. Mississippi. Yeah, Mississippi. That would be when that thing came on. That would be like saying, "Oh, I can tell the difference between 165 and 166 miles per hour." You know, give me a break. Even if they're right, it's incredible. The other big, I don't know if anyone saw the picture of the dying polar bear that went viral a couple of weeks ago. Well, it turns out that the mortality rate for polar bears has been remarkably consistent for the last 100,000 years. It's 100%. They're all going to die. There's 30,000 polar bears in the wild today, 4 times what there were in 1960. We see a steady increase in polar bears. Polar bears live about 15 years as their lifespan. In captivity, they can live as long as 30, but the bears in the wild lived about 15 years. That means about 2,000 polar bears die each year. The bear that was captured on film dying was one of those 2,000. And that's just an example of how the alarmist fraction uses heart-wrenching issues like this to reach out and raise money and promote their causes. We looked at sea level. We'll look again. This is the big picture of sea level. This is from, I have this all sourced and referenced in the book. This is 20,000 years of sea level data dating back to the end of the last ice age. And you can see that we went through a fairly rapid sea level rise. Sea level has risen about 400 feet since the end of the last ice age. But then we, in that period of accelerating sea level rise, starting about 6,000 or 8,000 years ago, sea level rise decelerated, and we're at about the same levels today as what we were back then. We're not seeing an acceleration in sea level. Good. And we saw this chart before. Again, this is a couple hundred years more detailed data on sea level. Again, relating that, we do not see an acceleration of sea level rise. I will say at this point, of all the climate apocalypse events, this is one that we need to address. Sea level rise. It looks to me, looking at the data, probably to you, the other warming periods continued to warm higher than what we are. I expect to see more warming, naturally driven. I expect it, and with that will come increased sea level. It's not going to become anywhere near at the rate that the IPCC and others predict, but it is something we're going to have to worry about over the next 100 or 200 years. And this is a look at the IPCC's charts by year on their predictions of what sea level will do. You can see back in with each successive 5-year assessment, that predicted sea level rise fell. So I guess it's still wrong. I'm pretty sure it's still wrong, but it's not as wrong as it used to be. Good. So what have we learned today? Everything that I looked at in terms of climate apocalypse and the rest it was turned on its head. My ideas that I had going into this were blown away by the science, the facts, and the data. And I know as Gordon and I'd send chapters to him, and he'd go, "Oh my God." He was just right, Gordon. We were going through it, and we were experiencing this, learning as we went, and just looking at each chapter, chapter after chapter after chapter, looking at the science, facts, and the data, which contradicted most everything we're being told. So go ahead. So the big overarching theme of my book is that rising CO2 and rising temperatures are doing really good things to the Earth's ecosystems and the world and the human condition. By every metric I looked at, again, we'll have to deal. Sea level rise eventually will be a problem, but not nowhere near the level that's predicted by the IPCC.